For problem numbers 7 through 10, we're changing polar to rectangular. And the main thing that you need to remember is that you're not allowed to have any r, and you're not allowed to have any theta. I can't stress that enough because it says you're changing polar to rectangular. It's just like when you're translating a language. Like if you just said, translate, where is the bathroom? And to Spanish, you would say, ¿Dónde está el baño? You wouldn't say, ¿Dónde está el bathroom? That would have some Spanish, some English. You don't want that. So when you're translating polar to rectangular, you can't have any more polar in there. You can't have any R's, and you can't have any thetas. Okay, so no ¿Dónde está el bathroom? Understand? R equals 8. So we have to remember the relationships here. X squared plus y squared equals r squared. We have x equals r cosine theta. Y equals r sine theta. Remember, the sine and the y are connected. The x and the cosine are connected. And then we have the tangent of theta is equal to y over x. Well, if r is equal to 8 and we square both sides, there's one way to get an r squared in there. That's what we want to do. We want to get an r squared in there so we can square both sides. R squared equals 8 squared. And look, we have r squared as a convenient x squared plus y squared, so we leave it alone. X squared plus y squared equals, and we can square the 8, and we have 64. That's it. For number 8, look at that. We have an r cosine theta, and that's exactly the same thing as x. So you just replace r cosine theta with x, and you're done. For this one, we could rewrite this as r equals negative 5 over the sine of theta. And so what this should prompt you to do would be to notice that we need an r sine theta, and the only way to get an r sine theta is if we divide both sides by r. So if we divide both sides by r, we get 1 equals negative 5 over r sine theta. And again, r sine theta is the same thing as y. And so we could probably want to write this, multiplying both sides by y, we get y equals negative 5, and we're done. Now, number 10 is another situation where we want to get an r squared, but if we square both sides, then on the left side we'd be fine. So remember, we squared both sides in problem number 7 because that allowed us to get an r squared, but it also 8 squared is a number we can deal with, and that didn't pose any problems. But if we square both sides here, then we would, okay, r squared, we would get that, and we'd be able to substitute the x squared plus y squared, but we would have a sine squared over here, and then we're running into some trouble here. We don't have a convenient translation for that. That was a bad word, but couldn't think of anything else. Anyway, if we square both sides, again, that's bad. If we multiply, though, both sides by r, that's another way of getting an r squared in there. And so if we multiply both sides by r, we get r squared on the left. And then look at how convenient this is. We can move that r right there next to that sine of theta, and we get 7r sine theta. And we now can go ahead and make our switch. R squared is x squared plus y squared, and the r sine theta, well, that's just y. And you can go ahead and leave it alone. That's good enough. We can just leave it. So let's go ahead and box all our answers here. We have x squared plus y squared equals 64. We have x equals 6, y equals negative 5, and then x squared plus y squared equals 7y.